Geotechnical Engineering Part A, Soil Mechanics Session 3. Let's derivate a bit more of weight-volume relationship. So we already talked about a few of weight-volume relationships. So that's a gamma prime, which is submerged unit weight, gamma D, which is a dry unit weight, and they are also increasing in from left to right. So gamma prime submerged unit weight is smaller than dry unit weight. Dry unit weight is smaller than a total unit weight. Total is smaller than saturated unit weight, and saturated is a bit smaller than the unit weight of soil itself. So, and we also proved them with the formula as well. So gamma prime is GS minus 1, gamma D, which is a bit bigger, is GS over something that's smaller than gamma T, which is GS plus GS times W, which is moisture content, and that's also smaller than GS plus void ratio. When SR is saturated ratio is 100%, gamma T will reach to gamma saturated, and yet gamma saturated is smaller than a the density unit weight of the grain soils itself. So let's, for example, go with the submerged unit weight. Mhm. And let's see how we can derivate gamma prime equation, which is GS minus 1 over 1 plus a void ratio times a unit weight of water. And also we do know gamma prime is saturated then unit weight minus unit weight of water. So if we already know gamma saturated is GS plus E over 1 plus E times gamma W, and gamma prime is just gamma saturate, which is this one, minus gamma W, which is a GS plus E over 1 plus E minus 1 plus E. We can factor out unit weight of water and then add these two together to get the same numeric value for gamma prime. GS plus, in denominator we have 1 plus E, common denominator for both of them, and in numerator we have GS plus E minus 1 minus E. These two are cancelled out and we are left with gamma prime, which is GS minus 1 over 1 plus void ratio times a unit weight of water, which we already uh, talk about it at the top here. So likewise, you can derive more relation from each other. So let's have a quick review on the equations. So dry unit weight is equal to, it's shown with two formula. One is GS over 1 over plus void ratio times unit weight of water, or there is a relation. Do you remember, if we have moisture content, we can convert a, a total unit weight and dry unit weight they have a mutual relation with. As soon as you know what the moisture content is, you can convert these two to each other. At the same time, for total unit weight, we have two formula. One of them is GS plus GS times moisture content over 1 plus void ratio times a dense unit weight of water, and also that's a gamma D plus saturated ratio times the difference between a saturated unit weight minus a dry unit weight. And gamma prime is also likewise shown by two formula, which we already derived them in the previous slide. That's, and gamma saturated is just GS plus E over 1 plus E times gamma W. You can show it with a something like a considered like a second approach, like GS times gamma, and but that's the more common, uh, that's more pronounced way to present gamma saturated. At the same time, void ratio is volume of void over volume of soil. E has a relation with porosity, and that's void ratio is porosity over 1 minus porosity. Likewise, porosity has it defined by volume of void over total volume. That's why we say E can be higher than 1, but porosity is all the time is a something like less than 1, because volume of void cannot exceed the total volume in any scenario. And also it has a relation with void ratio, that's n is equal porosity is equal to void ratio over 1 plus void ratio. At the same time, saturated ratio times void ratio is equal to water content times specific gravity. Mhm. And water content in percentage is a weight of water over volume, weight of soil. Weight of water over weight of soil is it's a moisture content. And if you want to relate that equation based off of their volume, you have to multiply 1 over GS to volume of water over volume of soil, and that's a useful equation as well. If you want to know what is the mass of soil, the grain of soil, that's if you have the total mass, mhm, divided by y plus over 1 plus moisture content, you can get the solid part of the material. And if you want to know what is a my bad, that's MW. If you want to know what is the solid part of material, that's ms, and that's a water mass of the material. That's a moisture content times the total mass over 1 plus moisture content. That's a water part of, or water mass of the mixture of three phases of soil. And at the same time, if you have a condition of soil, that's a gamma D1 dry density, dry unit 1 in a scenario 1 times volume 1 is equal to a dry unit weight of 2 times a volume of 2. That's a combination between a soil in different condition. Mhm. And that's also a very useful equation, just in case. At the same time, V2, if you have two volume of soil, that's the V of V, the second one over first one is 1 plus void ratio of the second one over 1 plus void ratio of the first one. Vs volume of solids is the total volume over 1 plus void ratio. They are just a kind of a review of some of the most common and important soil formula, which if you just remember, if you just have them in your cheat sheet, or you just get familiar, know to how to use them, it's very useful. So let's put them into an example. So for a moist soil, for a wet soil, the following are given. We do have mass at the left in kilogram and the volumetric value on cubic meter in SI at the right. So the total mass is 2350. Mass of water is 186.1 kilogram. Mass of soil is provided to be 2163.9 kg, and the volume of void is provided to be 0.402, volume of water is 0.186, and total volume is 1.2, Vs is 0.798. At the same time, the data provided is total volume, total mass, moisture content is 8.6 percentage, and specific gravity of soil, solids or grain are 2.71. So we want to calculate at a different a part, or in part A we want to know what the moist density is. And that's nothing but gamma total. You remember I told you that's gamma wet, that's gamma moist. Wet is moist. And in part B, dry density is just gamma D, gamma dry. Part C is void ratio, asking about what E is. Part D asking about N. Degree of saturation is SR. Volume of water in the soil sample is V of W. V of water. So let's see how can we solve the problem. So for the first part, it's just telling us what is the moist density. Rho, just in case in here, if it's just talking about a specific weight, so a gamma is nothing but rho times G. So rho again is density. We have talked about it last time, but just in case, in I think in session one, I talk about the difference between unit weight and density. So rho is density and a gamma is unit weight. So if you just want to know what the moist density is if for example a dry density is something, rho is just gamma over g, just in case. Gamma over g is for example rho. So that's a simpler approach. It means rho is mass over volume. So if we want to know what is the, because we are working not with unit weight but with density, so mass over volume is density, and our total mass is provided to be 2350 kg over 1.2 cube meters, and that gives us 1958.3 kg over cube meters. That's our moist density, because that's the total mass over the total volume, including water and air in terms of volume. Part B is dry density calculation. Rho D, rho dry is, so that's a, if it was gamma, it was Ws over V, that's mg. So let's put it into mass. Let's make it simpler. If it was gamma dry unit weight, it was W weight of soil over total volume. Now, do you remember I told you a rho times G is gamma? So rho D times G is gamma D. So if we want to know what rho is, it's just simply a gamma D over G, and Ws is ms times G. Mass is just removing the G from the equation. That's all you need to know. It's not a easy, it's just a matter of unit difference between density and unit weight. So we want to know what dry density is. In that term, we are working with only dry part of the material, so mass of soil over volume. If you remember with a formula revision, we told mass of the soil part of the mixture is total mass, which we have total mass here, over 1 plus moisture content, which again we have that, and that's provided in data problem statement, that is 8.6 percentage. So rho d is in that case ms over v. This is ms over V. So that's, if you replace it, we have a total, all of them are known. We have M total mass from here, which is provided. That's this amount. Uh-huh. Mhm. Over 1 plus 8.6 times 1. That's that give us rho d 1803.3 kg over cube meters. And at the same time, in part C, we want to know what void ratio is. Mhm. By void ratio, we want to know what E is, and we do know rho D is GS over 1 plus E times rho W. Like gamma D is equal to GS over 1 plus a void ratio times gamma W. For density, you just replace them with density. So if you rearrange this equation, it just gives you a void ratio is equal to GS, specific gravity, over a density of dry density, times density of water minus 1. If you do the math, it just gives you a void ratio of 0.503. In part D, you want to know what porosity is, that's N, and there is a formula which converts the void ratio to porosity, and that's E over 1 plus E. And if you do so, it gives you the porosity of 0.335. In part E, we want to know what the saturation ratio is, and SR times saturation ratio times a void ratio is a moisture content times a specific weight, a specific gravity. In that case, if you replace that for SR, you already know W, moisture content from problem statement, and if you replace it in the formula, it just gives you 0.463 in terms of moisture saturated. It means it's a 46.3 percentage of saturation. So our soil is a less than half saturated, our sample. So in part F, the volume of water is asked. So what if we want to know what is the mass of water over raw water? That's a total mass minus solid mass over rho W. That's total mass minus m times over 1 plus omega, and that over rho W, which is 1000 kg over cube meters, and that gives you 0.186 cube meters. You can solve this problem in a different approach as well. In solution 2, part A and B are identical to the same solution. So density is, in either case, is mass over volume. So it's like part A of solution 1. Part B, dry density, is also, again, rho is a mass over volume. So if you want to know what density rho gamma d, rho d, gamma t, rho total, gamma wet, gamma saturated, a rho saturated, what they are different uh, description of unit weight or density. So we can have we have density transformed to different conditions. So one time it's completely dry, one time I think this is the same kind of material. This is density, but different a behavior of density. One time it's dry, one it's 65% wet, and one time is fully saturated. So they are a different a behavior of unit weight or density. That's how easily they are transformable to each other. So raw dry dry density is drain mass over the total volume, and grain mass is mt total over 1 plus omega, and it's the same like I told you part A and B are identical to solution 1. But in part C, in calculation of void ratio, we do know for any material, density times volume gives us the mass. Mhm. So if we want to know what is the rho for solid part, that's rho W times a density of a specific weight of our material, either plastic, soil, whatever we have. So that's a conversion of getting the rho s from rho of W. You just multiply it by the specific weight of a specific gravity of the material you have, which in our case, that's soil. Mhm. And it just gives you the mass of soil. And as soon as you have the mass of soil, so if you just rearrange this equation for V of S, volume of solids, that's a, we already know what our MS is. It's provided here. Mhm. Or you can calculate it over GS, which is provided in problem statement to be 2.71 for our soil grains, and times a density of water, which is 1000 kg over cube meters. And that gives you volume of soil. And then what? Void ratio. Do you remember void ratio is volume of void over volume of solids. So as soon as you have volume of solids, volume of void is provided. So that's 0.402 over 7. So if you already calculated volume of solid in previous slide, and VV, volume of void, is V minus Vs. Mhm. It's also provided here, but you can also calculate it as well. I do recommend do it either way. Then a void ratio is volume of void over volume of solid grain. So in that case, that's a 0.503. With a different approach, we get the same void ratio because our sample is not changing. It's the same a void ratio, porosity, and whatever you're calculating. And but that's a, I think that's a easier approach and uh, um, more related to understanding the concept of those calculation. And in part, the porosity is just a N is volume of soil over the total volume. Mhm. So if you, sorry, my bad, that's a volume of void, volume of void over volume of, that's volume of void, not soil, over total volume. That gives you this much over total volume, and that's 0.83. And in part E, we want to know what the saturation ratio is. Mhm. And saturation ratio is the amount of water. Do you remember the tap? That's amount of water in terms of volume, which fills the volume of void. Mhm. So we do know volume of water is mass of water times density of water. We already know what the mass of water is over density of water, which is 1000. It gives us a volume of void, which that's a in terms of cubic meters, meter cubed. And then as soon as you have volume of water which fills the void, we already have the void, and that's a 1.186 over 0.402. It's again 46.3 percentage of saturation, which is our sample is less than half saturated, or almost half saturated. And part F, we already calculated volume of water. In from part E, we do know what our volume of water is mass of water over rho of water. This is mass of water over 1000. We already calculate this part. Thank you. We are going to solve a more interesting example in geotechnical engineering. Thank you.